Hello, good morning, everyone. My name is Maite, and it's a pleasure for me to take the next 5 minutes of your time to share with you the project that we are developing as part of the Ph.D. in chemical engineering here in BUAP. Aloe vera is a well known and widely used plant in our country. However, the production of derivatives from this resource may be affected due to soils contamination. In response, in this project, we are working on a bioremediation process targeting the root of this plant, also known as savila. It is known that many of the crops in the state of Puebla and most of surrounding areas are irrigated with wastewater. No? What happened that this water carries metal that for this project we refer to as potentially toxic elements, PTEs, and which tend to accumulate in soils, in roots, and in many cases in the plant themselves. So, aloe vera, apart from its household, medical, and self-generative use, also holds great potential for remediating contaminated soils, but assisting in the containment of pollens. But however, when the plant is used for the production of goods, this natural process becomes a challenge when seeking high quality standards in the food, or cosmetic, or in pharmaceutical sectors. The aim of this project is to isolate and use plant growth promoting bacteria, PGPB, in aloe vera plants to study the mobility of potentially toxic elements within the system. So the expectation is that these bacteria will help to stabilize these elements in the root zone, meaning the bacteria through their metabolism will assist in specifically some of the next points. The first point is retaining contaminants in the root zone. That's what we call phytostabilization. The second point is solubilizing nutrients for better plant availability. Next point, reducing stress levels in the plants. Other point, regulating the plant's hormonal balance. And finally, promoting optimal plant development. This will result in improved raw material quality for the production of high export grade products, finally. For methodology, we are focused principally in 4 steps. The first one is to isolate plant growth promoting bacteria from soils where aloe vera is cultivated. The second one is to isolate plant growth promoting bacteria, but now from mining tailing soils. That's for having different kind of bacteria. The step number 3 is to evaluate PGPB characteristics, such of them as phosphate solubilization, that's for nutrient availability. Other characteristic is indole triacetic acid production. This compound is for phytohormone production. Other characteristic is siderophore production. This is to qualify or quantify for iron acquisition. And the last characteristic we want to evaluate is ACC deaminase production. That means 1 aminocycle propan, 1 carboxylate deaminase for stress reduction in plants. And this characteristic was for the 3rd step, the 3rd step. And the 4th is conduct kinetic process analysis using a biological model, which involves measuring factors such as transfer factor, translocation factor, and bioremediation factor for all elements that we are studying in this project. And these are arsenic, cadmium, chromium, and lead. At this point of the PhD, we have been studying some characteristics in PGPBs, but just in bacteria from aloe vera, from the soils where aloe vera is cultivated. Now we don't have bacteria isolate in mining tailing soils, so we are working on this part to evaluate characteristics, but just in soil where aloe vera is cultivated. Finally, it is worth noting that this biotechnological system, assisted by bacteria, are generally well received due to their low cost and efficient results, potentially benefiting to the producers of these crops.